what are some of the things that you remember about vectors from last year? So we had 2D stuff, right? So last year we did 2D. And what kind of things can you remember about our vectors? Pardon? So we've got I and we've got J. Do we remember what they were and what we called them? Right, so x-axis and y-axis. Come on, kids. Do we remember how we can write vectors? Okay, so your textbook will write them like this or like this. You might see me every now and again write it like that because for predominantly most of my teaching, that's how we used to write it, with square brackets horizontally. But now it's vertically they do it. So what is I? It's a special vector. 1, 0, that's right. 1, 0, 1, 0, 1, 0. And what length does that have? It has a length of 1, and that gives it a special name. What is that called? The unit vector. Okay, so J is the same as 0, 1. We make sure that we call, you don't have to write all of this stuff down because I will give you a summary in a minute. Right, unit vector, which means it has a length of 1. So that brings up a couple of things. 1, how do we find the length of a vector? Seriously, I will give you this. Don't need to write down. How do we find the length of a vector? Do you remember? I heard someone talking before and they said Pythag. Pythag, right, because remember, when we're talking about a vector, if I had vector 3, 4, that means I'm going across 3, I'm going up 4, and yes, we looked at this with complex numbers, so it should not be anything brand new to you, right? So that's how we get, if I wanted to find the unit vector of this, so it's in the same direction, but instead of having a length of, yeah, I'm just thinking, how was I going to write? I didn't want to write that again, but thank you. Yes, I knew it was 5. Instead of having a length of 5, I want it to be length of 1. How do we find the unit vector? So a vector in the same direction. Now, Moses, you're hurting me here because I do have a summary that I will give to you. But if you want to write it down, you can, but I will give this to you. All right? But feel free, I don't want to stop you. So how do we find a vector in the same direction, but unit 1? Do you remember? Mac, what did you just look at? Yes. Yep. You divide it by the length, basically, right? So if we have, let's say, vector A, and we'll call that A1, A2, then the unit vector that is in the same direction of A will be 1 over the length of A times A1, A2. Is this coming back to you a little bit? Okay, you might be thinking, why is she doing all of this? Well, I'll tell you in a minute. What if we said it was parallel? What happens then? What does parallel mean? Same length, but, it doesn't even have to be the same length, does it? But if I want a unit vector in the same length, a unit vector, well, it has got length 1. But what happens, what's the change, Finn, if it was parallel instead of same direction? Ooh, stumped him first thing in the morning. So it means it can go the other way. Same length over the same thing. So how do I indicate that? Plus or minus. Okay? So if it's the same direction, we keep it as plus. If it's parallel, that's when we have the plus or minus. Sweet? Anything else you remember from units, from vectors that we did last year? We did a lot. Bearings and stuff, yeah. To do with angles. We could find the length, the angle between two vectors. Yeah? Remember that? Anyway, that's beautiful. What else? I'll give you a clue. Oh, I was about to go. The clue was this. Dot product, right? Dot or scalar product. So if I had two vectors, let's take, God, it's in the morning, so we'll just keep it nice and simple like so. 2, 1, and 3, 4, right? How do I find, do you remember how we find the dot or scalar product? Right, 2 times 3 plus 1 times 4, it's 10, and this was pretty much irrelevant. We use this as part of finding the angle between two vectors, but otherwise it was really useless unless it equaled a special number. 0. What happened if it said it was equal to 0? What does that tell us about our vectors? Pardon? Not same length. 90 degrees perpendicular, okay? So if your dot product equals 0, that means the two vectors were perpendicular, okay? We happy with all of that sort of stuff? We're remembering a little bit? Now, you might be going, why are we doing all this? Well, in a moment, you're about to do everything that we did. Everything? Most of the things that we did last year, but instead of A and B, or X and Y, we've now got Z. X, Y, and Z. But guess what? Your unit vectors, oh, and by the way, we've still got I as our unit vector, but instead of being 1, 0, anyone want to have a gander? Anyone want to have a gander as to what it would be? 1, 0, 0. Then we've got J, which would be 0, 1, 0. And you guessed it, A, B, C, D, E, F, G, H, I, J, K. Right, so what's going to happen, hopefully, is that this is all going to be very logical. Going from 2D to 3D is nothing that bad. It's all the same, right? How do you think we find the length of a 3D vector? It's going to be the same thing. So if I've now got a vector, it's now, instead of A1, A2, A1, A2, A3, right? The length of the vector still uses the same notation, okay? And lo and behold, it's going to be the square root of A1 squared plus A2 squared plus A3 squared. Oops! A3 squared, okay? Same deal. How do you think we're going to find the unit vector of a 3D? Same deal, right? Just find the length times through by 1 over. Remember, someone said divide through by 5. Who was that? Max said divide. Can we remember? Do we divide technically? No. So remember that we use 1 over something. We would never write this. And I know that's what you meant, Mac. But I know he doesn't mean, he wouldn't say that divided by 5. He would never write it like that. I know him, right? But just remember that's a little thing. Same deal with the scalar product. You times the X components plus the Y components and the J components. And can anyone remind me, why is it called the scalar product? Only has length, not direction. Okay, magnitude, right? It's a number, it's a scalar. So scalar is a magnitude thing, a size, not an angle. Sometimes people get all caught up and they would write this as 6, as a vector 6, 4, and you go, no, it's not a vector. So remember, scalar. Same thing applies. Okay, so that's where we're heading. And hopefully you can sort of progress along your merry way, working your way through, I think, is it chapter 5? Without too much intervention on my part, but I'll be there to back you up just in case you want it. So let's have a look. To save your minds a little bit, please have a look at the axes. I think it's better if we can just look at something simple like so. Oops. Hopefully you can see that I was not lying to you when we talked about the magnitude, the length of a vector, the Darcy blows. I guess the only thing that's a little bit different is when it's asking you to plot a point. Do you know what? If you want to have a little bit of a play with that, you can. However, when we do some stuff with this, we're going to use some software and it will plot all of that for you. So it's nice to understand, but you don't need to spend ages and ages physically plotting it yourself unless you've got a little bit of time up your sleeve and you want to play. But have a look at this. So first off, these are our axes. So instead of y up the top, y comes out here and x is this way. Okay? You have technically the negative values for x going that way. You've got your negative values for y going that way, and of course your negative values for z going downstairs. Okay, so if we're looking at this, 0, you are not moving in any direction. You're staying put. If it was like 1, 2, 0, then you would come out here as 1. You'd go across 2, and then you're not going up at all. Does that make sense how we just maneuver it? But again, I'm not going to be worried at all if you go, yeah, I don't want to plot. As long as you can sort of understand the space. So we're happy that it's not moving left to the outwards here. It's going across 2 and then it doesn't move up or down. So same with B, you can see it's come out here by 3 along the x-axis. It hasn't moved anywhere this way along the y, and then it's gone up by 2, so that's our point there. And I'm sure you can read the rest, or might as well do it. So this one, minus. Instead of coming out to the positive, it's gone back, across 2 and up 3, and that's how we get it. So you can see it makes that 3D shape. So any of you who have done CAD, who have done is it CAD? Yes. Yeah. The 3D stuff, you're probably going, oh God, yeah, of course. It is better when you see it with software. All right. You can see working out the length, very, very simple. So really, if you have a look at what we're going to be running through, very, very quickly you are going to be just reminding yourself about some of the basics of 3D. I'm not going to ask you to plot the points. If you want to, sure, you can. Do we need to do this? I'd like to think, no, skip-a-rooney, right? A take 4 has to equal 1. Well, I think A is 5. Like, come on. Same sort of thing. Let's skip. All right, 4. Tell me how you do it. What's the key here? Right, it's when it says, yes, unit vector's 1, be more specific. Jado, what did we say about unit vector? What is 1? 1 unit in length, right? So we're looking at the distance formula and we're saying it has to equal 1. Looks like we have to do this from the pause that we just had. Okay, so let's pop our, get our books open. If you wanted to put this down as exercise 5A, sure. Oh, look. Was it last year? A couple of years ago, we actually named him. I've forgotten who it was, but someone in the class looked like this. And so every time this chap came up, we said, oh, that's such and such, giving us the heads up. And for the life of me, I can't remember who it was. Okay, so I know it's been a while since you did all this stuff, but find K given that this is a unit vector, so we would straight away rock into, right, minus a half squared plus K squared plus 1/4 squared. Now you could say all square rooted equals 1, or couldn't you just say equals 1 squared, right? I'm looking ahead when we're doing these sorts of things. Very simply, I could say instead of this being a unit vector, I could say it has length 4. So then blah, 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 blah equals 4 squared, 16. Yeah? So just be aware how you can change these things pretty quickly. yes, you could reach for your calculator, but not yet, because what can we do here? We know that k squared would be 1 minus, what's a half squared? What's a quarter squared? And sure, if you wanted to, you could use your calculator at this point. And then just remember that when you get k, when you square root, what's your answer? It could be plus or? Yeah. So it could be plus or minus, whatever. So I had planned on skipping that whole section, but anyway, that's okay. Vectors in algebra, we know that we can add, subtract. Yeah, pretty basic. We don't need to do that. Blah, 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 blah. Ooh, what about our calculator? Can we check this stuff on our calculator? Do we remember? So can everybody grab our calculators and let's see how can we put in one of these vectors, and let's see if we can work out 2a take. Okay, so to pop in a vector, but we will go options in a minute, but we go math first, right? So F4, mat vectors, and then we can see here we've got a 3 by 1 and we can pop that in and we can just do what we need to. When we go to option, we've still got another maths and matrices there, and that allows us to do certain things. So that's where we find our cross product. I think it will give us unit vector, the angle. I don't know. Oh, vector. Can I just pop that in? Vector. I don't know. I don't ever use that. Yeah, I've never used that. But one of the things as you're going through, you know, fool around, see what your calculator can do. But yeah, look at that. Gives you unit vector. If you're going to that to find your unit vector, that's not good. You should be able to do that yourself. What else is there? Ooh, the normal vector, which we'll come up with a little bit later. Anyway, so know that those things are there. Get used to using your calculator swiftly if you need to save yourself some time. All right, back to. So happy to skip all of this. I don't think this has got much to do, like 4, that hasn't got much to do with vectors. That's just saying, well, 2 times that, so 2 would have to equal your b. And so on. Are you happy that I'm just going skip? Skip. Common properties, I think that's pretty basic, except probably this one is useful. Again, if you get your revision guides, have they been able to be purchased yet? Nobody knows? It's okay. We've got those, you know, summaries at the back of them, and I'll give you a copy of those anyway when we get to it. This is what we talked about before, no dividing. Okay, so they'll be hot on this, has no meaning. Vector algebra, again, you know, I'm wanting to skip. We happy? Thank you. If you're not, by all means, feel free, go back and do. Right, one of the things we didn't cover was how do we find the vector between 2 points? So remember, if we go AB, we want to say B take A. Do you recall that? So if I've got 2 points, A and B, the vector between those 2 points, AB, is B take A. Because we're coming from 0. You know, your chewing gum is very bothering me, and you'll be scraping and cleaning in the bin. That was Kunal, who's chewing gum in my class. In the bin. Right, so 5D. I would like you to go through, if you think you are really confident and you're going, yeah, I've got this, maybe double check and find OA, and you don't have to do all of them, right? Just find one, or feel free to go through and do them all. There's a couple of bits in there I think are really good, just reminds you of some things, but it sort of summarizes the things that we've just skipped. Are we happy to work our way through? Right, you'll find interesting things like this. Find the shortest distance from this to the y-axis, the origin, the YZ plane. Think about that. All right, if you get stuck, I will help you out, but have a think. So there will be some bits and pieces where you go, ooh, but we'll see how far you can get by your lonesome. All right? Love you. Carry on from 5D.